A compass lies in the hand, its needle trembling, wavering, unable to settle on north. For a traveler, such failure means disorientation. For a civilization, it is far more. It is the loss of anchor, the collapse of certainty, the realization that direction itself may be an illusion. The universe, too, once seemed to offer a compass. Philosophers imagined absolute space, a great stage upon which the drama of existence unfolded. Time was believed to flow like a universal river, constant for all. This was the north that guided. Physics for centuries, a fixed frame against which every motion could be measured, every truth aligned. But discovery after discovery stripped away that certainty. Experiments revealed no ether wind, no universal medium through which light moved. Einstein shattered absolutes, showing that motion and rest, past and future, depended on perspective. Quantum mechanics deepened the confusion. Particles without fixed paths, probabilities without direction, the very act of observation shaping the outcome. And yet, the human mind still longs for a compass, for a universal orientation, a cosmic north pointing toward ultimate truth. Is there any such frame in the vastness of reality? The cosmic microwave background seems to whisper of one, but its patterns are ambiguous, its signals uncertain. What if the universe truly has no privileged direction, no anchor at all? What if space, time, and even existence itself drift in a sea without fixed bearings? The haunting question remains, if the cosmos holds no compass, then where do we point our search for meaning? The story of the missing compass begins not with stars or galaxies, but with human hands carefully building instruments, with minds daring to ask whether the universe hides a preferred direction. For centuries, the assumption seemed obvious. Surely space and time themselves must provide a universal frame, an ultimate north against which all else is measured. Yet every attempt to hold that compass steady revealed only deeper uncertainty. The dream of the ether in the 19th century, physics was a house built upon waves. Sound moved through air, rippling vibrations in matter. Water waves required oceans and rivers. Light, too, was a wave, so surely it required its own medium. Scientists called it the luminiferous ether, an invisible fabric thought to permeate the cosmos, carrying light the way air carries sound. If the ether existed, then Earth must be moving through it like a ship through water. There should be a detectable ether wind, shifting the speed of light depending on direction, a compass of sorts, written into the fabric of reality in 1887. Albert Michelson and Edward Morley set out to detect this wind with exquisite precision. Their interferometer was designed to measure tiny changes in the speed of light as Earth orbited the Sun. If the ether were real, the needle of physics' compass would point clearly to its flow. But the needle never moved. The experiment revealed no trace of the ether. Light's speed was constant, unyielding, the same in every direction. The compass of absolute space pointed nowhere. This was the first great fracture. The universe had refused to provide a fixed direction. Einstein's revolution 2 decades later. Albert Einstein offered the radical framework to explain the failure. In his theory of special relativity, there was no need for ether, no absolute backdrop for space or time. The speed of light was constant for all observers, regardless of their motion. Space and time themselves were not fixed coordinates, but elastic measures woven into the act of observation. Einstein's general theory of relativity, published in 1915, expanded the vision. Gravity was no longer a force, but the curvature of space-time itself. Planets orbited not because of invisible tethers, but because space-time was warped, guiding their paths. Relativity erased the idea of a universal compass. There was no absolute rest, no privileged frame. All motion was relative, all directions equally valid. The universe had no single north, no cosmic axis against which everything could be measured. It was a profound liberation and a profound disorientation. Humanity had lost its compass at the very heart of physics. The cosmic microwave background for half a century, relativity reigned. The universe expanded, galaxies fled apart, and still no compass revealed itself. Then, in 1965, a discovery changed everything to engineers. Arno Penzias and Robert Wilson, working with a radio antenna in New Jersey, stumbled upon a persistent background noise. It was not interference from Earth, not the echo of nearby stars. It was relic radiation, the afterglow of the Big Bang itself, stretched into microwaves by billions of years of expansion. This cosmic microwave, background, CMB, became a new kind of compass. It was the oldest light in the universe, emitted when the cosmos was only 380,000 years old. To map it was to see the universe's baby picture, the closest thing to a universal reference frame. When satellites like COBE, WMAP, and Planck later mapped the CMB in exquisite detail, they revealed a striking uniformity. The cosmos looked the same in every direction, nearly perfect in its balance. But embedded in this uniformity were tiny ripples, anisotropies that carried the seeds of galaxies, written in the earliest fluctuations of the universe. More intriguingly, scientists detected a dipole anisotropy, a difference in temperature, across the sky caused by Earth's motion relative to the background. It was as though the CMB offered a cosmic rest frame, a backdrop against which our movement could be measured. Had physics found its compass again? A cosmic north written into the very afterglow of creation. The illusion of direction, the answer, was less simple. The CMB revealed our motion through space, but not a universal direction. It was not the compass of an absolute cosmos, but the reflection of our local path. The universe itself remained without anchor, its expansion without center, its geometry without edge. Each apparent discovery of a compass dissolved upon closer inspection. The Michelson-Morley experiment showed no ether. Relativity abolished absolute frames. The CMB suggested a backdrop, yet offered no true north. Each revelation gave a glimpse of order, only to reveal deeper ambiguity. The compass needle still wavered. The central theme emerges this. Was the pattern of modern cosmology, every attempt to locate a universal orientation, exposed instead the absence of one. The search for ether failed. Relativity denied absolutes. Quantum mechanics replaced certainty with probability. The CMB offered the illusion of a compass, yet only confirmed the relativity of motion, and so a deeper question emerged. Perhaps the problem was not in our tools, but in our assumptions. Perhaps the cosmos does not hold a universal north at all. Perhaps the compass pointing nowhere is not a failure of science, but the fundamental truth of reality. A new horizon by the late 20th century. Science had gathered its fragments, the absence of ether, the relativity of motion, the isotropy of the microwave background. The needle of the compass had been sought in the smallest experiments and the largest maps of the sky. Yet still, it refused to point. The stage was set for the next revelation, that the absence of direction was not an accident, but the very nature of the universe. That the cosmos itself is a sea without anchor, a vast expanse where the compass cannot settle, because there is no ultimate north to find. This realization was not gentle. It was shocking, disorienting, and deeply unsettling, a scientific discovery that challenged not only physics, but the human desire for orientation. The compass pointing nowhere was not the end of the story. It was the beginning of a new mystery. The discoveries of the early 20th century did more than refine physics. They overturned its foundations, pulling away the ground upon which certainty once stood. What began as subtle experiments and elegant equations became a revelation so unsettling that even the greatest minds struggled to accept it. The compass of the cosmos, once assumed to point toward absolute direction, now pointed nowhere at all. The collapse of the ether, the Michelson-Morley experiment, had seemed almost trivial in its aim to measure the difference in light speed as Earth sailed through the supposed ether. Yet its null result shattered centuries of belief. For generations, the ether had been thought of as the invisible stage upon which all motion occurred, the ultimate frame of reference. Without it, the compass of physics lost its north. Space was not a substance, not a medium. It was something stranger, something emptier, yet more mysterious. Physicists were stunned. To them, the universe without ether seemed as incomplete as an ocean without water. But the failure to detect it left only one conclusion. The compass needle had no north to find. Relativity's denial of absolute Einstein gave this disorientation a name and a framework. Relativity. No experiment, he declared, could reveal absolute motion. The laws of physics were the same for all observers, regardless of their speed or direction. To grasp this was to let go of centuries of assumption. There was no universal stage, no fixed background. A traveler on Earth, a photon speeding across the galaxy, a planet orbiting a distant star. All were equally valid perspectives. There was no privileged point of view, no cosmic compass aligning them. Time itself lost its universality. Two observers in different states of motion would disagree on simultaneity, on duration, even on the order of events. The river of time, fractured into many streams, each relative to its observer. The shock was not only scientific, but philosophical. Humanity had long believed in absolutes, in anchors that held reality firm. Now the anchors dissolved. Direction, motion, and even time itself were revealed to be relative, contingent, without universal orientation. Quantum mechanics. The compass dissolves further as relativity dismantled absolutes on cosmic scales. Quantum mechanics dismantled them on the smallest dot in the quantum realm. Particles no longer followed clear trajectories. Electrons orbiting atoms did not move in neat paths, but in clouds of probability. Photons traveled as waves of possibility, collapsing into a definite location only when measured. The compass needle, once imagined as pointing to certainty, now wavered perpetually. A particle could not be said to move this way or that until an observation forced its decision. The universe at its foundation was not built of certainty, but of ambiguity. The very act of measurement became strange. Observers no longer stood apart from reality. They shaped it, collapsing possibilities into outcomes. The compass, it seemed, was not only missing, it might never have existed at all. The terror of directionless reality together, relativity and quantum mechanics painted a cosmos unlike anything imagined. On the largest scales, no absolute rest, no privileged direction. On the smallest, no definite paths, no fixed certainties. The compass humanity longed for a universal orientation. A cosmic north had vanished. Every experiment that tried To reveal it instead confirmed its absence. To some, this was exhilarating. It meant the universe was deeper, stranger, more open to discovery than ever before. To others, it was terrifying. If there is no absolute frame, no universal direction, then perhaps reality itself is without anchor. Perhaps meaning too must drift. The human struggle with certainty. Einstein himself wrestled with the consequences. Though he created relativity, he resisted the indeterminacy of quantum mechanics. God does not play dice, he declared, unwilling to accept a universe without certainty. Niels Bohr, his contemporary and rival, replied with calm conviction, "Einstein, stop telling God what to do." It was more than a debate between physicists. It was a clash of worldviews, one yearning for a cosmic compass, the other accepting its absence. And in the decades that followed, experiment after experiment confirmed quantum mechanics' predictions. Particles behaved as if probability were fundamental. The compass needle of physics pointed nowhere, and that nowhere proved to be reality itself. The shock made visible by the mid-20th century, the implications of relativity and quantum mechanics, reached beyond laboratories. Time dilation was measured in fast-moving particles and orbiting satellites. Quantum entanglement, Einstein's dreaded spooky action at a distance, was confirmed in experiments linking photons across kilometers. Each confirmation deepened the shock. The compass did not merely waver, it dissolved. There was no ether, there was no absolute time, there was no universal direction. There was only relativity on the grandest scales, probability on the smallest, and human minds suspended between them, searching for orientation where none could be found. The question that haunts physics: why does the universe refuse to provide a north? Why is there no absolute frame, no hidden stage? Is it because reality itself is built not on certainty but on relationships, not on absolutes but on symmetries? Or is there a deeper compass still hidden, a structure beyond our reach, waiting to be uncovered? The shock of the 20th century was not only that physics had lost its compass, it was that perhaps it was never meant to have one. The search for direction revealed instead the directionlessness of reality, the unsettling possibility that the compass pointing nowhere is not a failure of science, but the fundamental truth of existence. The shock of relativity and quantum mechanics left physics suspended in a strange new reality, one without absolutes, one without a compass. Yet the human mind is relentless in its search for orientation. If no universal direction could be found in the ether or in time, perhaps it could be found in the afterglow of creation itself. The next step was to look deeper, further back, to the most ancient light the cosmos still carries, the cosmic microwave background. A new candidate for When Penzias and Wilson stumbled upon the faint hiss of microwaves in 1965, they had uncovered the universe's oldest relic, the cosmic microwave background, CMB. This light, emitted nearly 14 billion years ago, when the cosmos was still in its infancy, was a frozen echo of the Big Bang. To physicists, the CMB seemed to offer more than relic radiation. It appeared to provide something relativity had denied, a kind of universal backdrop, a canvas against which motion could be measured. NASA's COBE satellite, launched in 1989, mapped the CMB and revealed it to be astonishingly uniform. The temperature differed by less than 1 part in 100,000 across the entire sky. The universe, it seemed, had no preferred direction. The compass pointed nowhere, but embedded in this near perfection was an anomaly, a slight dipole anisotropy, a temperature difference across the sky. Earth, and indeed the Milky Way itself, was moving relative to this cosmic backdrop at nearly 370 kilometers per second. The CMB had no true north, but it allowed us to measure our drift. It was a strange half-answer, not an absolute direction, but a mirror showing us our own motion, a compass needle trembling, not to the cosmos, but to ourselves, WMAP and Planck. A universe in exquisite detail in the early 2000s. The Wilkinson Microwave Anisotropy Probe, WMAP, sharpened this picture, mapping the CMB in far greater detail. The ripples it revealed were the fingerprints of the infant universe, tiny fluctuations in density that over billions of years seeded galaxies and stars. By 2013, the Planck satellite refined this map to extraordinary precision. It confirmed inflation's predictions, showed the universe's geometry to be flat, and measured its age to remarkable accuracy. Yet, in its data lurked patterns that unsettled cosmologists. Some anomalies hinted at alignments on scales larger than expected. The so-called axis of evil, a peculiar correlation in the temperature fluctuations, seemed to suggest the universe itself might have a preferred orientation. Could it be that the compass needle, dismissed by relativity, pointed faintly? After all, the temptation of an axis-to idea of a cosmic axis is intoxicating. If the universe has an orientation, then perhaps it has an ultimate reference frame, a direction, woven into the fabric of space-time itself. But the evidence is slippery. Many scientists argue that the axis of evil could be a statistical fluke, a trick of chance amplified by our longing for order. Others caution that it could be an artifact of measurement, a subtle bias in how data was gathered or processed. Still, the possibility lingers. The compass needle flickers, unsteady, raising the question, is the cosmos truly directionless, or have we simply not looked closely enough? Beyond light, particles as probes. While cosmologists mapped the sky, particle physicists sought direction. In the smallest scales, could the laws of physics themselves reveal hidden asymmetries, subtle breaks in the universe's apparent neutrality? Neutrinos, ghost-like particles that pass through matter almost unhindered, became a focus. There, oscillations between different flavors revealed physics beyond the standard model. Some theorists speculated that neutrino behavior could hint at asymmetries in the universe's earliest moments. When matter triumphed over antimatter, then came the Higgs boson, confirmed at CERN in 2012. Its existence proved that even empty space is not truly empty, but filled with a field that gives particles mass. Yet the Higgs field appeared uniform, without orientation. Once again, the compass pointed nowhere. Quantum vacuum fluctuations. Deeper still lies the quantum vacuum, seething with fluctuations, particles and antiparticles appearing and vanishing in an endless foam. To the human mind, it seems chaotic, without order, without direction. Yet from this chaos, structure arises. Inflation itself may have been driven by such fluctuations, magnifying randomness into galaxies. Here lies the paradox. The quantum vacuum offers no compass, no preferred direction, and yet it gave rise to a universe structured, patterned, filled with stars and life. Out of directionlessness came form. Out of the compass pointing nowhere came the cosmos itself. The puzzle deepens. Each layer of investigation reveals the same strange truth. The ether is gone. Relativity erases absolute frames. Quantum mechanics dissolves certainty. The CMB is uniform, yet with hints of alignment. Particles and fields appear symmetrical, yet conceal asymmetries we do not yet grasp. The compass needle trembles, but never settles. Each new discovery answers one question, only to reveal another. The echo of a deeper question is direction itself. An illusion is the search for a cosmic north misguided, the attempt to find a fixed point in a universe where none exists. Or is there a hidden axis still undiscovered, a deeper symmetry that binds the cosmos and anchors reality? Science does not yet know, but the investigation continues, each probe a hand reaching into the darkness. Each discovery another flicker of the compass needle. The deeper we look, the more profound the mystery becomes. A universe that insists on symmetry, yet tempts us with whispers of direction. A cosmos that gives us the tools to measure our motion, yet denies us an absolute frame. The compass, it seems, is both present and absent, a paradox written into the sky. The search for a universal compass had already collapsed into disorientation. The ether was gone. Relativity stripped away absolutes. Quantum mechanics dissolved certainty into probability. The cosmic microwave background, nearly uniform, offered only a faint dipole of our own motion, and perhaps illusions of an axis hidden in noise. But the mystery did not rest there. As the 20th century gave way to the 21st, new revelations made the puzzle even more extreme. Far from yielding direction, the universe seemed to insist that direction itself was a mirage. The expansion without center in the late 1920s, Edwin Hubble discovered that distant galaxies are receding from us, their light stretched into red by the expansion of space. It was natural, at first, to assume that this meant we were at the center of the cosmos, that the compass needle pointed outward from our own place in the void. But relativity denied such privilege. Expansion is not from a point, but of space itself. Every galaxy sees every other galaxy moving away. The compass points outward everywhere, yet nowhere in particular. This was the first escalation. The universe expands, but without center, without origin. Its growth denies direction, even as it drives galaxies apart at unimaginable speeds. The shock of dark energy in 1998. Astronomers measuring distant supernova made a discovery that deepened the mystery further. Not only is the universe expanding, it is accelerating. Some unknown force, dark energy, is pushing the cosmos apart, faster and faster. If dark energy is uniform, then it offers no axis, no direction, only an all-encompassing pressure without source. If it is not uniform, if it hides structure we do not yet see, then it could hint at an orientation deeper than the cosmic microwave background. Either way, it left physicists adrift. The universe was racing apart, yet with no compass to show. Why or where? The multiverse implication eternal inflation theory added still another layer. If our universe is only one bubble among many, born from fields collapsing elsewhere, then each universe may have its own laws, its own orientation, its own north. But if countless universes exist, each with its own compass, then none is absolute. The very idea of a universal north dissolves into infinity. For every compass pointing one way, another points elsewhere. The multiverse does not restore direction. It abolishes it entirely. Entanglement and the death of location quantum mechanics added another escalation in the form of entanglement. 2. Particles, no matter how far apart, can share a state instantaneously. To them, separation is meaningless. Direction and distance lose their familiar meaning. If entanglement extends beyond particles, if it is woven into the fabric of space-time itself, then here and there may be illusions. Location may not be fundamental, and if location is not fundamental, then direction cannot be either. The compass pointing nowhere is not only a feature of cosmic expansion, it may be the very nature of quantum reality. The threat of false vacuum decays. If this disorientation were not enough, particle physics raised a more terrifying possibility. The Higgs boson's measured mass suggests that our vacuum, the state of space itself, may not be stable. It may be a false vacuum, a plateau of temporary stability perched above a deeper state. If so, then collapse could occur. A bubble of lower energy could form and expand at the speed of light, rewriting the laws of physics. In such an event, even the illusion of direction would vanish, erased by a new universe with new rules. The compass pointing nowhere might not only describe the present, it might foreshadow the end. The paradox of deeper maps. Every attempt to map the universe with greater precision, whether through galaxy surveys, CMB, anisotropies, or gravitational wave detectors, sharpens the paradox. The more we map, the clearer it becomes that no ultimate axis emerges. Patterns appear, anomalies tempt, alignments whisper of hidden order. Yet with every refinement, the universe shrugs them off. The compass needle trembles, but will not settle. The human fear for a species that has always sought orientation. The implications are profound. On Earth, the compass needle points north, anchoring journeys, giving meaning to place. To imagine a cosmos without equivalent anchor is to imagine drifting without reference. Suspended in an ocean of relativity, it is not only a scientific unease, but an existential one. If there is no cosmic direction, then perhaps there is no cosmic purpose. Perhaps meaning itself, like direction, is not discovered but made. The escalation of mystery, what began as the simple failure to detect ether, has expanded into a revelation of terrifying scope. The universe accelerates outward with no center. Quantum entanglement dissolves the meaning of distance. The multiverse implies infinite compasses, each cancelling the other. The very vacuum beneath our existence may one day collapse. Each discovery escalates. The same conclusion. The cosmos provides no north, no anchor, no final direction. And yet, in that disorientation lies the central mystery, for perhaps the compass pointing nowhere is not an error but a truth. Perhaps reality itself is directionless, built not on absolutes but on relations, not on orientation but on possibility. The compass needle, trembling without anchor, has become one of the most profound metaphors in modern science. Every experiment that sought a cosmic north has instead revealed the absence of one. And yet, the human mind does not rest with absence. It builds models, frames, and visions to understand why direction itself refuses to exist. Theories abound, some grounded in relativity, some born of quantum fields, others spun from the edges of speculation. Together, they form a constellation of possibilities for why the compass of the universe points nowhere. Relativity. The death of absolute north. Einstein's relativity remains the foundation. Its principle is simple and devastating. There is no privileged frame of reference. No observer can claim rest while all others move. Every point of view is valid, every orientation equally real. Relativity dissolves the notion of absolute direction, because space and time are not fixed, but relational. A photon moves at light speed not because of an ether wind, but because space-time itself enforces this symmetry. The compass cannot point north, because in relativity, north is always relative. This is not illusion. It is law written into the geometry of space-time itself. Quantum field theory. The uniform vacuum quantum field theory extends this symmetry. It envisions the universe as a web of fields, electromagnetic, weak, strong, gravitational, each filling all of space. The vacuum is not empty, but a stage of seething fluctuations. Yet these fields are uniform. They have no preferred orientation, no direction pointing outward into the cosmos. They may ripple with particles and waves, but the average state is symmetrical. The compass needle points nowhere, because the fields of existence themselves have no north. They are isotropic, directionless, endlessly neutral. The temptation of CMB anomalies and yet anomalies persist. The so-called axis of evil in the CMB tempts with the possibility of hidden alignment, that the universe itself might carry a subtle orientation. Some argue this could be evidence of new physics, perhaps a large-scale anisotropy in the fabric of space. Others dismiss it as coincidence, the inevitable statistical oddity when mapping the sky of infinite complexity. If real, it would mean the compass does point faintly somewhere. If false, it is only another mirage in the desert of meaning. The holographic principle, direction as illusion. Another speculation arises from black hole physics. The holographic principle. It suggests that our three-dimensional universe may be encoded on a two-dimensional boundary, like a hologram projecting an image. If true, then direction itself may be emergent, not fundamental. The compass needle points nowhere because space is not what it seems. Orientation is a projection, an echo of information rather than a deep truth. In this view, the cosmos is less a place with directions than a story unfolding in data. The multiverse, infinite compasses. Infinite now's inflationary theory and string landscapes point toward the multiverse, an endless collection of universes, each with different laws, constants, and symmetries. In one universe, the compass might point north. In another, it might point elsewhere. In countless others, it points nowhere at all. But taken together, these compasses cancel. There is no universal orientation across the multiverse, only local rules in local worlds. Our compass pointing nowhere is not an anomaly. It is the natural outcome of infinity. Entropy and the arrow of time amid this directionlessness. One arrow remains time. Unlike space, which offers no absolute direction, time seems to move inexorably forward. Entropy, the measure of disorder, increases, giving rise to the arrow of time. Some speculate that the only true compass is not spatial but temporal. North is not in the sky but in the future, defined by the growth of disorder, the decay of stars, the slow heat death of the cosmos. Yet even this arrow is not fully understood. Why should entropy increase? Why did the universe begin in such a low entropy state? If time's arrow itself is contingent, then even this compass may be no more absolute than the rest. The paradox of meaning together. These theories paint a paradox. Relativity insists there is no absolute direction. Quantum fields offer a vacuum without orientation. Anomalies tempt us with possible axes, only to dissolve in uncertainty. Holography hints that direction is illusion. The multiverse denies any universal compass by multiplying them into infinity. Entropy gives us time's arrow, but without explaining why it exists at all. Every speculation deepens the central truth. The compass points nowhere, because reality itself may be fundamentally without anchor. The poetic vision for science, this absence is explanation. For humanity, it is poetry. To live in a universe without compass is to live in freedom, unbound by absolutes, open to possibility. It is also to live in fragility, suspended in a cosmos that offers no ultimate north, no final orientation. Theories try to tame the compass, to explain its trembling. But perhaps its trembling is the explanation. The compass points nowhere not, because we have failed to find direction, but because direction is not a fundamental property of existence. The compass of the cosmos wavers, refusing to settle. Theories multiply, speculations expand, yet the question persists. Does the universe hide a preferred direction, or is its refusal to grant one the deepest truth of all? To probe this riddle, science has built instruments of unprecedented power. Telescopes that stare back to the birth of time. Colliders that recreate the energies of creation. Detectors so sensitive they can hear the faint trembling of space-time. Each is a compass of a new kind, reaching into the unknown, searching for the faintest trace of orientation in a cosmos that insists on none. The cosmic microwave background, searching for anisotropy CMB, remains the most powerful tool in the search for direction. The COBE, WMAP, and Planck satellites mapped its faint glow with increasing precision, revealing both its astonishing uniformity and its subtle anomalies. Future missions, like CMB's 4, promise even sharper clarity. These observatories will probe for anisotropies, so slight they may reveal whether the universe has hidden axes, faint signatures of asymmetry imprinted at the dawn of time. If a true cosmic alignment exists, it will be written in this ancient light. If not, the CMB will confirm once more that the compass needle points nowhere. Large-scale surveys, galaxies as maps, the great web of galaxies is another compass of sorts. Surveys like the Sloan Digital Sky Survey, SDSS, have charted millions of galaxies, revealing filaments and voids stretching across the cosmos. Upcoming projects, such as the Vera C. Rubin Observatory and ESA's Euclid mission, will map billions more, tracing cosmic expansion and clustering with unmatched precision. If hidden asymmetries exist in the distribution of galaxies, these surveys will expose them. But so far, the universe appears isotropic on the largest scales. The compass remains mute. Dark energy investigations, the discovery of dark energy, the mysterious force accelerating cosmic expansion, added urgency to the search. Is dark energy perfectly uniform, or does it hide structure? If it varies across space, it could provide the faintest whisper of direction. Instruments like the Dark Energy Spectroscopic Instrument, DESI, and NASA's Nancy Grace Roman Space Telescope will measure the universe's expansion history in exquisite detail. If dark energy is not constant, if it ebbs or flows with orientation, then the compass needle may twitch. If it is uniform, then direction once again dissolves into nowhere. Gravitational wave observatories, listening to space-time gravitational waves, first detected by LIGO in 2015, offer a new window. These ripples in space-time, born of colliding black holes and neutron stars, carry with them information about the geometry of the universe. The future LISA mission, a space-based gravitational wave observatory, will listen for waves at longer wavelengths, perhaps even whispers from the inflationary era. If primordial gravitational waves are detected, they may reveal whether the early universe favored any direction. So far, the waves hum in neutrality, their music without compass. But science listens still. Particle accelerators, symmetry and its violations, deep beneath the Franco-Swiss border. The Large Hadron Collider smashes protons together at near light speeds. Its goal is not only to discover new particles, but to probe the symmetries of the universe itself. The Higgs boson revealed that empty space is filled with a field giving particles mass. But does the Higgs field have hidden asymmetries? Could violations of symmetry point to a deeper orientation of reality? Experiments search for violations of charge parity CP symmetry, small imbalances between matter and antimatter. These may hold clues to why matter exists at all, and whether the universe hides preferences beneath its apparent neutrality. So far, the symmetries mostly hold. The compass needle remains trembling, indecisive. Quantum experiments, entanglement and collapse in laboratories. Quantum physicists stretch entanglement across ever greater distances, linking photons and particles across kilometers, even satellites in orbit. These tests probe whether quantum mechanics is truly without orientation, whether entangled states ignore space entirely. Quantum computing experiments, manipulating particles in superposition, ask whether the collapse of wave functions reveals hidden directions. If collapse is influenced by gravity, as some suggest, then space-time itself may anchor quantum uncertainty. But each result points again to symmetry. Entanglement holds across distance. Collapse resists directional bias. The compass points nowhere. Even in the smallest realms, the horizon of future tools, the coming decades promise new instruments of breathtaking power. CMBs 4, Rubin, Euclid, Roman, LISA. Each will map, listen, and probe deeper than ever before. Proposed colliders larger than the LHC may reveal hidden fields. Space-based quantum experiments may test entanglement across Earth's orbit. Each tool is built to answer the same question. Does the universe hide direction, or is its refusal the final truth, the limit of science yet? Even as tools grow sharper, limits remain. If the universe truly has no preferred direction, no experiment can reveal one. If other universes exist, each with its own compass, their signals may never reach us. If space-time itself is emergent, then orientation may be illusion, never testable. At all, science may map the trembling of the compass, but never find it settling. The very structure of reality may deny it, the human reflection, and yet the search continues. For in the act of searching, humanity confronts not only the cosmos, but itself. The machines we build are not merely instruments of physics. They are instruments of longing. Every detector, every telescope, every accelerator is an extension of the same desire, to find anchor in a universe adrift, to hold a compass steady in the void and see it point, if only once, toward truth. Perhaps the compass will never settle. Perhaps that is the answer. But in the attempt, in the endless reaching, humanity finds meaning, a direction of its own, chosen not by the cosmos, but by the will to know. The journey of the compass has carried us from the failure of the ether, through the revelations of relativity, into the strangeness of quantum mechanics, and out across the faint glow of the cosmic microwave background. Each step has been guided by the same hope that somewhere in the fabric of reality, the needle would settle, pointing us to an ultimate direction, an anchor in the abyss. But the compass has not yielded. It trembles still, wavering without north, refusing to align. And in its refusal, it leaves us with a question far larger than physics. What does it mean to live in a universe without orientation? The compass, a symbol on earth, the compass is a promise of stability. Its needle always pointing north allows the traveler to chart a course, to find meaning in movement. It transforms chaos into journey, wilderness into map. In the cosmos, the absence of such a compass is unsettling. We are wanderers on a sea without north, explorers without chart, beings adrift in a universe that denies any fixed frame. The compass pointing nowhere is not only a scientific discovery, it is an existential symbol, the loss and the liberation to some. This loss is disorienting. Without a cosmic north, the universe seems indifferent, void of purpose. If space holds no anchor, if time flows differently for each observer, if quantum reality dissolves paths into probabilities, then perhaps meaning itself is unmoored. Yet in this absence lies liberation. If the universe grants no direction, then none is imposed upon us. The compass pointing nowhere means that meaning is not given but created. Orientation is not discovered but chosen. We are free to chart our own paths, to define our own norths. In a cosmos that offers none, the arrow of time and yet one compass remains, not in space, but in time. Entropy increases, disorder grows, and the arrow of time points forward. It is the only universal orientation we know, the only direction upon which all observers agree. But even this arrow is shrouded in mystery. Why did the universe begin in such an ordered state, allowing entropy to rise? Why does time seem to flow when the equations of physics are symmetrical, equally valid running forward or backward? The compass of time points, but we do not know why. It is as haunting as the silence of spatial direction, a reminder that even our one universal arrow may be more fragile than it seems. The mirror of humanity, in the trembling compass, we see a reflection of ourselves. Human beings long for orientation, for truths that are fixed, for absolutes that anchor existence. The loss of cosmic north is not only a loss for physics, it is a challenge to the human spirit, and yet it is also a mirror of our own condition. Like the universe, we are without ultimate compass. We live lives filled with choices, drifting without certainty, orienting ourselves not by absolutes, but by values we create, meanings we choose. The cosmos offers no anchor, and in that it resembles us. The beauty of directionless existence, perhaps the compass pointing nowhere, is not tragedy but beauty. For in directionlessness lies possibility. If the universe imposed a single orientation, a single truth, then all else would be excluded. But in its absence, all paths are open, all directions valid. This is the poetry of a cosmos without north, that in its refusal to anchor, it grants us freedom to wander, to wonder, to become the final imagery. Imagine again the compass, its needle trembling in the void. It points nowhere, yet in that trembling it reveals the deepest truth of existence. The universe is not a map with north inscribed, but a sea of possibilities, a fabric of relations without anchor. We are the travelers, carrying the compass through the dark. It may never settle, it may never point, but in its silence it whispers something profound, that meaning is not found in direction, but in the act of searching, in the journey itself. The cosmos points nowhere, and in that nowhere we discover our own north.